Assalamu alaikum everyone. My name is Arish Asif Khan and I warmly welcome you to today's lecture. Today we're going to dive into an exciting topic that I'm sure you'll find both useful and interesting. So let's get started. Group number and valence electrons. The group number of an element in the periodic table helps us to identify the number of valence electrons and the charge of its ion. For S block elements, their group number will be equal to the number of valence electron. It basically means that if I have group 1, that means that the valence electron will also be 1, and if I have group 2, the valence electron will also be 2. Now for P block elements, the number of valence electron is equal to the group number minus 10. For example, the group number is 18, so 18 subtracted from 10 will be 8. So that is the number of valence electron of precious gases or noble gases. Now electron loss and gain. Elements tend to gain or lose electrons to achieve a stable noble gas configuration. Now the elements with 1 to 3 valence electron lose electrons to form positive 1, positive 2 or positive 3 canions, and elements with 5 to 7 valence electrons gain electrons to form negative anions. Basically, in simple term, this means when you have an element and it loses electron, it has a positive sign and it forms a cation, and when you have an element which gains an electron, it has a negative sign and forms a anion. Now examples of groups are, for example, the group 1 are known as the alkali metals. That means they have one valence electron which is the same as their group number, like lithium, sodium, potassium. They form one ion because they have an electronic configuration of 1s1, or it can be changed, but they will never have a complete duplet or octet. Now group 2 alkaline earth metals, they have two valence electrons. Example of these valence electrons are beryllium, magnesium and calcium. And in group 17 you have halogens. They have 7 valence electrons. Why? Because 17 has been subtracted from 10, which means 7. Now fluorine, chlorine and bromine are examples of halogens. Now in group 16 you have chalcogens. They have 6 valence electrons. They are known as oxygen and sulfur. And then the group 18, which are known as the noble gases or precious gases, they have 8 valence electrons, but except helium, which has an electronic configuration of 1s2. Now for example, I have fluorine. Fluorine's electronic configuration is 1s2, 2s2 and 2p5. But if you remember, the P block must contain a maximum of 6 electrons, but in fluorine the P block has 5, so it will gain 1 electron, which means that it will form an anion, and fluorine's sign will be negative as it is written here, which means 1s2, 2s2 and 2p6. Now fluorine, when it formed an anion, it basically has changed its electronic configuration to a stable noble gas. Why? Because 6 plus 2 is 8, which is forming a complete octet. Another example is of chlorine. As you can see, the electronic configuration is the same, in which the P block has 5 electrons but it needs 6. This means that chlorine will have a sign of negative and the 5 will be changed to 6. This formed an anion. Now let's have an exercise. If I want to find the valence shell configuration of aluminum, you need to have the atomic number. I have the atomic number, which is 13. You need to find the electronic configuration, and then you need to check how many valence electrons are needed. So you can check from that how many valence electrons are needed, or you can even find the group number, the valence electrons and which block it belongs to. As such, aluminum belongs to group 13, period number 2, and it has the total valence electrons of 3. Why? Because 2 plus 1 is 3, so 3 plus 10 is 13. It belongs to group number 13, and 13 minus 10 is 3. It means that the valence electron is 3. Another example is of sulfur. The atomic number is 16. As you can see, the electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p4. So 3p4, it belongs to the P block. First point noted. and 4 plus 2 is 6, which means total valence electrons in sulfur are 6. 6 plus 10 is 16. It belongs to the third period. It has total of 6 valence electrons and it belongs to the 16th group. I hope you found this lecture helpful and informative. If you did, make sure to subscribe to my channel and hit the bell icon so you can never miss a future lecture. Thank you.